So HR, so we have the results. Now one thing that we would like to do is to build a heat map. In order to do this, we should focus on the top genes. So we will start to subset the table. So in this case, we use a subset statement. You see that there is a table argument. We can choose the original table or the results table. Let's go with the results table. And this will produce another table called subset. It will have the same columns as the source of the subset statement, because subset only removes rows, not columns. And now we have to decide how do we want to filter. So if I press Control space a couple times, I alternate between this error message, no variance for filter, and two choices. When true or with IDs. Let's focus on when true. So when true asks for an expression that you can use to filter the rows of the table. So subset rows will keep only the rows when the expression is true. You can refer to columns, values in the columns of the table to filter the rows, and you do this with the dollar column expression. So you press the dollar, and now you have access to the different columns that are defined in the source table, and we are going to filter by FDR, the first one here. So we want to filter by FDR, but we also want to, so let's say we want less than 5% FDR. So one error message that shows up is that base language is needed. You actually can simply import it with this intention here by accepting the intention. Notice that I accepted the intention, but there's still an error highlighted here. I can close the editor tab and reopen it again, and this error was just something that was not refreshed, so actually it's fine now. I will call the subset table 5% FDR. And notice that I have a space in the table name, but it doesn't really matter because MetaR handles those cases without problem. Once I've created the subset, if I look at the table, I realize that I have the gene IDs, I have the FDR, which allowed me to filter and keep only the 5% FDR top results, but I don't have any counts, so that's a problem to create the heat map. The counts, however, were in this table that was used as a source, right? We actually annotated each of those columns with the counts attribute. So one thing I can do here is I can use the two tables, the results and the counts, and I can join them. So I'm going to use a 5% FDR, I'm going to use a counts table, and I'm going to group by ID. I want to group by the gene ID, and both tables have this ID group, so I can actually simply indicate that. So this table now is called results again. I don't like this because there's already another table with that name, so I just call them joined. And if I refresh, you'll see that the join table now has all the columns from the counts, right, on the annotation. So CDC has counts on LPS no, but I also get the p-value column and the FDR column. So all of that is in the same table. So now I can actually use the heat map statement, build the heat map, so I can accept that, and as input I want a table, so I'm gonna use the join table that we just created. It's telling me now that okay, there's a problem because my table does not have any column with a usage called heatmap, and so this is something we need to change. So because I know that I want to show only LPS yes and no, I will actually create a heat map usage here, and I will add it to those two. Heat map. Okay, so LPS yes, LPS heatmap, LPS no, LPS heatmap. And if I go back, this error message disappears because now the heatmap statement knows which columns to use to render the heatmap. But we can also actually be more precise, and if we had many groups, we could actually refine this here. So we could say I want to use a group LPS no, and I want to use a group LPS yes, and I will put this on the heatmap. We have to name the plot, and in this case I just call it heatmap. Okay, so we can run the script, and it's automatically generated to our code on run under the hood. So it runs again the differential expression. Okay, so it's happier in this direction because there are more elements in this table than in this one. Heatmap, we can have a look. Okay, this is what it looks like. It's probably too big. We might want to reduce the number of genes that we're looking at, 1% FDR, and also increase a little bit the width and probably the height to 600. And we can rerun the script and see what happens. Okay, so we have an execution. If you take the cursor away and again, on top of it, you see that you have more results here. So one thing we could do to make this heatmap look a little better is to add annotations. We could add the groups. We want to already show the LPS group, and let's run this again. This should add a bar with the colors showing the two groups and the legend to the heatmap. So here we are. Here are the two groups. So we can't really see much in terms of differences, and the reason is that if you look at the legend, those numbers are fairly big. So we actually need to scale the values to make it possible to see small differences in fold change. So we scale by row, and the rows are genes in this case. So we're going to scale within a gene to make smaller differences easier to see. So we rerun again. When the statement, when the execution is finished, you will notice that it's actually much easier to see differences between those groups. Another thing that we could do to make it easier to see is to cluster by gene. So we can change this attribute to cluster by row, and this should put genes that have similar expression together, closer together in the heatmap. Okay, and this is a result with clustering now, and you see that it's much easier to see that there are sets of genes that are overexpressed here in the LPS no group, and sets of genes that are overexpressed in the LPS yes group in slightly different patterns. And then this here, there's one sample that seems to be a bit different from the others in terms of those genes here. Okay, so this is how you would create a heatmap with MetaR, starting from a table that we have annotated, running a differential expression, taking the subset of genes that are within 1% false discovery rate based on the test, on multiple testing correction, joining the table of results with the counts, and then constructing a heatmap from those counts. The last thing that you might be interested in doing is actually to make a PDF out of this heatmap. And you can do this with the render statement. You are prompted for a plot. Again, you use auto-completion and you locate the heatmap. And here you use auto-completion to accept the only choice, which is PDF. you need to provide a file name, heatmap.pdf, and you need also to provide a style. So you could actually, there's a style available here. You can name it, and here we are. Okay, and once you run this, this will create the heatmap.pdf file inside the results directory where MetaR stores results. You can find out what the directory is by simply looking at the generated code. This is actually on my machine where the heatmap is created. So let's take a look. So this is file name where the file was created. I open the file. I see that the heatmap actually is a bit truncated. So one thing you could do is see if you click on the render node, you have the width of the plot in inches and the height in inches. So here we're going to describe that we want to plot that 6 by 10. That might work, and you might have to try different values of those parameters to see what works best in your case. And we will rerun. This is still the old file, so I have to close this window, reopen it, and here now the file is actually looks much better. And this is a PDF, so you have vector resolution.